Hello students. Last day we discussed about the Riemann-Tiemann reactions, and Riemann-Tiemann reaction where phenol react with chloroform in presence of sodium hydroxide at 65 to 70 degrees centigrade, and it produce orthohydroxybenzaldehyde or salicylaldehyde as a major product. And this reaction goes through via carbene intermediate. This is very important, that Riemann-Tiemann reaction goes through via carbene intermediate. Later we discuss about, instead of chloroform, if we use carbon tetrachloride, then the product will be salicylic acid. If we use carbon tetrachloride instead of chloroform in presence of sodium hydroxide and 65 to 70 degrees centigrade, then the product will be salicylic acid. And the reaction mechanism of this reaction same as Riemann-Tiemann reactions. So what is the reaction mechanism? In presence of sodium hydroxide, actually the reaction does not go through via carbene intermediate, rather than there occur electrophilic substitution reactions. When you use chloroform with this phenoxide ion, carbon tetrachloride with this phenoxide ion, this is carbon tetrachloride, then benzene ring act as a nucleophile, attack to the carbon center, and chlorine minus ion remove as a leaving group, and it will produce and after hydrolysis and after aromatization, this is the aromatization step, and when you hydrolyzed this product in presence of acidic water, then it produce geminal hydroxide, and this type of geminal hydroxide is very unstable, and a rearrangement type reaction occur just like this, and it produce salicylic acid. So this is the reaction. Today we discuss about the Gattermann reactions of phenol. So what is Gattermann reactions? When phenol react with hydrogen cyanide and hydrochloric acid in presence of a Lewis acid, for example aluminum trichloride, that when phenol react with HCN, that is hydrogen cyanide, and hydrochloric acid in presence of LCl3, which is act as a catalyst, then it produce a intermediate step, that is imine. This is an intermediate step, and this carbon nitrogen double bond known as imine bond. So this product actually produced as an intermediate, and after hydrolyzed, this intermediate imine complex transfer into para hydroxy benzaldehyde. This is the product. So you can say in Gattermann reaction, phenol react with hydrogen chloride and hydrogen cyanide in presence of LCl3 to produce para hydroxy benzaldehyde. This is para hydroxy benzaldehyde. So what is the mechanism of these reactions? Here HCl and AlCl3, first reactions occur between these reagents, and you know this is hydrogen cyanide, and this chlorine minus ion actually came from HCl, which is attached to this carbon center, and this carbon nitrogen triple bond will break and it produce and this N minus ion abstract hydrogen from HCl to produce this complex. After that, AlCl3, which is act as a Lewis acid, abstract electron from this chlorine atom and generate a electrophile just like this. Next, this carbon chlorine bond will break and it produce a electrophile, and this electrophile actually plays a major role in Gattermann reactions, where phenol act as a nucleophile and due to steric hindrance here para product is the major product and it will produce this imine intermediate step. And when you hydrolyzed this imine, then this carbon nitrogen bond actually transfer into carbon oxygen double bond and it produce aldehyde. So this is the Gattermann reaction of phenol. Next, phenol also participate in a reaction with formaldehyde to produce benzyl alcohol or orthohydroxybenzyl alcohol and para-hydroxybenzyl alcohol, and this reaction actually known as Lederer-Manse reaction. So the next reaction is Lederer-Manse reaction of phenol. Lederer-Manse reaction. So what is Lederer-Manse reaction? Here phenol react with formaldehyde in presence of sodium hydroxide and water, and second, after hydrolyzed it produce orthohydroxy benzyl alcohol and parahydroxy benzyl alcohol. And again, due to steric hindrance, this orthohydroxy benzyl alcohol is a minor product and parahydroxybenzyl alcohol act as a major product. So what is the reaction mechanism? You know, here use sodium hydroxide and formaldehyde. So in presence of sodium hydroxide, phenol transfer into phenoxide ion. This is phenoxide ion, and this phenoxide ion act as a nucleophile, and this formaldehyde ion, this formaldehyde molecule act as a electrophilic center, and after reaction it produce and when it is aromatized occur in this way, and it will produce orthohydroxybenzyl alcohol as a major product. So this is Ladder-Manser reactions, where phenoxide ion act as a nucleophile and formaldehyde act as electrophilic center. So this type of reactions occur. Next one, reduction of phenol. Reduction of phenol. You know, in presence of hydrogen and nickel, at 160-degree temperature, all double bond of benzene ring reduce to produce a alkene or single bond. So all this double bond, carbon-carbon double bond, will be reduced in presence of hydrogen and nickel, which is act as a reducing agent, and is transferred into cyclohexanol. So this is the reduction of phenol. And next one, Birch reduction. So what is the Birch reduction? In Birch reduction, phenol react with sodium and liquid ammonia to produce this product. So this type of reaction known as Birch reduction. Here also double bond reduce, but reaction occur in different way. So what is the mechanism of this Barch reduction? Here sodium, which is act as a electron source, and it transfer into Na plus and a electron, and this electron actually attack to the benzene ring. So electron this electron actually attack to the benzene ring to produce this. And actually it abstract H plus ion from liquid ammonia, which also act as a proton source to produce this product. And this portion participate in ketoenol tautomerism. So actually it performed a ketoenol tautomerism just like this, and produce a keto product. So this is the final product of a Barch reduction. So these are the few reactions of phenol, and this is very important. So today we discuss about the Gotterman reaction as well as Lederman's reactions and reduction of phenol. So thank you.